Today is comparing rational numbers. We've done a little bit with this already when we did the inequalities, which number was bigger, greater, or less than. So we're going to focus on today on the weird ones, the ones that maybe are a little harder to tell the difference. You know, whole numbers, it's easy. 10 is bigger than 5. 3 is bigger than -3. You know, those are pretty easy, but sometimes they're a little bit more difficult to tell apart. And that's what we're going to focus on today. So trick number 1, for fractions. If you're trying to compare fractions and they're two really different fractions, you need to get a common denominator and then compare them. So looking at the example, the first one is by fifths. The second one is by 25ths. So to make them match, so you can compare which one's bigger, you need the bottoms to match. So to turn the 5 into a 25, you have to multiply by 5, which means you have to multiply the top by 5 as well. You always multiply by the same number over itself. So that gives you 35 over 25, which is much easier to compare with 34 over 25. Obviously, 34 is less than 35, so the small end goes on the 34 over 25. So it's much easier to tell which one's bigger when the bottoms are the same. Let's do the same comparison here. That's a 4, that's a 3. When in doubt, you can always multiply them by each other. So I'm going to multiply the first fraction by 3 over 3. That gives me 9/12. I'm going to multiply the second one by 4 over 4. That gives me 20/12. Now that the bottoms match, it's really easy to tell that 20/12 is a lot bigger than 9/12. So small end on the 9/12, which means small end on the 3/4. So that's the first trick. Get a common denominator, and then you can tell which one's bigger. All right, trick number 2. Decimals. For decimals, if you're having a hard time figuring out which one's bigger or smaller, what you're going to do is fill zeros on the right and then compare them without the decimals. Okay. So let's look at this one. You've got 1, 2, 3 decimal places with a 1. This one also has a 1, and it has 2 decimal places. So what we're going to do is we want the decimal places to be the same in both numbers. So I'm going to add a filler 0 to that one, so they both have 3 decimal places. Now we're going to write them without the decimal. So 1007, 1040. So now we have 1007 and 1040. Obviously 1040 is bigger, so the big end goes on the 1040, which means the big end goes on the 1.04. All right, let's look at number 2. 1.38 and 1.82. I think most of you could tell which one's bigger, but if you can't, they both have 2 decimal places, so we don't need to fill a 0. So just toss the decimal out. 138, 182, and then compare them. So obviously 182 is bigger than 138, so the big end goes on the 182, which means the big end goes on 1.82. Now, if they give you one where they have a positive number and a negative number, this is your freebie, because you know negative numbers are always smaller than positive numbers. So you don't have to even do anything on this one. You could just go, look, that's negative, small end on the negative. So don't forget the easy ones. All right, so now we're at the bottom. We're going to learn some number families. So for you who like to draw, this is we're going to make a visual diagram of the different number families. All right, so what you're going to do, make sure you can see the whole thing. I want you to make a really big space all the way around. So anything inside that space is a real number. And the symbol for real number, capital R with a bar. Now, we don't get into imaginary numbers in Algebra 1, but there actually is a separate family here with imaginary numbers. These are the ones with like the italicized I on them, like the 3I. But that's algebra 2. We don't really do much with imaginary numbers in algebra 1, but that is a separate number group. All right, inside the real numbers, there is a large category called rational numbers. I'm going to use the number symbol for numbers. And then there is a smaller family of irrational numbers. Now, if you remember from what we did yesterday, a rational number is a number that you can write as a ratio or a fraction. An irrational number cannot be written as a ratio of two numbers. So any number you can write as a fraction, as a ratio, is a rational number. Inside rational numbers, you have a large family, and then two smaller families. All right, inside rational numbers, you have integers, you have fractions, you have decimals. So examples of fractions are what you would expect, like -3/4 or 1 2/3. Those are all different kinds of fractions, positive and negative. For decimals, you could have a positive 0.02 or a negative 0.7. Decimals are positive and negative. All right, integers. Integers are positive and negative whole numbers. So they go to infinity. So we're going to just write a few of them. -3, -2, -1, 0, 1, 2, 3, and then they go to infinity again. So all those are integers. They're like positive and negative whole numbers. So we can break integers into a small family and another family here. Integers can be positive and they can be negative. Negative numbers are obviously, you know, -3, -4, -1. Those are all negative integers. Positive integers, you know, 2, 3, 5, all the things to the right on the number line. All right, last two families. Inside the positives, figure it out. Inside positives, you have what's called whole numbers. Whole numbers start with 0 and go up. And then inside whole numbers, this is our last family, you have what's called natural numbers. Natural numbers are the numbers you naturally start counting with when you're a kid, when you're a baby. And we start with fingers, right? 1, 2, 3, 4, 5. Your natural numbers start at 1 and go up. 0 is not a natural number. If you ever ask a little kid to show you 0, they will totally not be able to wrap their head around the idea of nothing. They just can't, which is why the natural numbers are things you can count on your fingers. Okay, I forgot to fill in irrational numbers. Pi is an irrational number. It can't be shown as a fraction. Anything trapped in a radical is irrational. And anything that is non-repeating, non-terminal, which means never ends, never repeats. So like 1, 2, 3, 4, and keeps going. All right, let me show you how to read the chart. If I give you the number 2, 2 is a natural number. It is a whole number. It is a positive number. It is an integer. It is rational, and it is real. So 2 has a lot of names. If I do like a -4, it's negative, it's an integer, it's rational, it's real. If I give you like 1.5, that's a decimal, which is rational and real. So that's how you read the chart, is whichever circle it's sitting in, that's what type it is. Okay, so right now, next to this 1/2, I want you to list all the names that the number 1/2 falls under and put them right there. Go ahead, list all the names that 1/2 falls under. And I'll just tell you, 1/2 is like right here. That's your 1/2. So go ahead and write the names. Oh, you're not trying to get your half of this. Some of you are like, I love this chart. Some of you are like, I hate this chart. It just depends if you're a visual thinker or not. All right, so 1/2. 1/2 is definitely a fraction. It's definitely a rational number. And it's also a real number. I'm just going to put the R. All right, let's try the 0. So here's our 0. So 0 is a whole number. Now, this one's hard because 0 doesn't actually have a sign, but it's difficult to show that with this chart. 0 doesn't have a sign. 0 is not positive or negative. It's just 0. But it is an integer. It is rational. And it is real. So 0 is kind of special. All right, any questions?